So Newton's first law, also known as the law of inertia, is an object in motion stays in motion at the same speed until acted upon by an outside force. In this video coming up, you'll see the lady pulls her arrow back, and as it's released it goes the same speed if you're not counting air resistance and all that, and it stops when it hits the deer. Now Newton's second law is acceleration is produced when a force acts on a mass. In this video you'll see this guy pulls back his arrow, which builds up force, and he releases it, which that force produces an acceleration on the arrow. Now here I've got an equation for the arrow that he was firing. We're trying to fire a 18-gram arrow, which comes out to 0.018 kilograms, and we want to move it at 100.28 meters per second. So you multiply the two, which gives you 1.81 joules, which is the force required to move the arrow at that speed. Newton's third law is for every action there is an equal but opposite reaction, and when you knock your arrow or you attach it to the string and pull back and then release, the string is pushing on the arrow and the arrow is pushing on the string with an equal force. The last thing I'm going to talk about is elastic potential energy or spring energy, and that's the potential energy stored as the result of deformation in an elastic object. And the equation for that is 1/2 kx squared, and k is the constant in newtons per meter, and x is the amount of bending in meters. Here you'll see a guy pulls back his bowstring, which builds up elastic energy, which can then be released as kinetic energy in the arrow. So here's an equation for his bow setup. We want to move the arrow back 0.737 meters, which is around 29 inches, and the spring constant for his bow is 340 newtons per meter. So if you take half of 340 newtons per meter times 0.737 meters squared, you get an elastic potential energy of 125.29 joules.